All right, so yesterday we talked a little bit about arithmetic sequences, and today we're going to get into the other sequence, which is geometric. So while you're looking at the screen already, it's asking you which do you prefer. So read through that really quickly and think about which one you would rather have. Okay, it says, which would you prefer, being given $1 million or 1 penny the first day, double that penny the next day, and then double the previous day's pennies, and so on for a month? Most of the time I have students say they just want the $1 million and they don't want to have to count the pennies. So we'll see by the end of this lesson which one you prefer. All right. So like I said, today we're going to be doing geometric sequences. This is section 9.3. The biggest difference between arithmetic and geometric is that if you remember from yesterday, arithmetic means we are adding to get to the next term. So geometric is going to be a little bit different. So let's look at these sequences. Okay, so maybe the first one's a little bit more difficult to kind of see, but if we look at this one down here, we find ourselves multiplying by 3. So then if we want to find the next term of the sequence, we take 27 times 3, which gets us 81. If we notice down here, we're multiplying by 2. So then if we find the next part of our sequence, it would be 32. Okay, so kind of like with arithmetic, if we are wanting to figure out what we are adding each time to get to the next term, we were able to subtract going backwards. So if we're not sure what we're multiplying by, we can always go backwards by division. So if you notice, we're multiplying by 0.5. And if I wanted to find the next term of the sequence, I just multiply 0.25 by 0.5 to get 0.125. So if you notice the biggest difference with arithmetic and geometric, we are multiplying. And that will be on the next slide, of course. Okay, so the common ratio, that's what we call it instead of the common difference. The common ratio is what we are multiplying by to get to the next term. You see our examples from the last slide. And just as usual, if you need to pause the video so you can make sure you write everything down in your notes, you're more than welcome to. I'm going to go ahead and move on. Okay, go ahead and try these 4 examples. Okay, so if we notice on the first one, we are multiplying by 2. So then we should get 48. Again, the difference between arithmetic and geometric is that we are going to be able to switch between positive and negatives. If you notice on this one, we're actually multiplying by a -3. So then we end up with a positive 162. Down here in the corner, if you notice that we're going down in numbers, which means we are technically dividing by 3, but our common ratio in this case would be 12 over 36, which reduces to, as my mind left me there just a second ago. Okay. Again, we could do the same if we did 4 over 12, also get 1/3 as well. So my common ratio here would be 1/3, and I think that's what we're technically looking for in all of these. So then if we do 4 divided by 3, of course, we're going to get 4/3. However, this one over here, if we notice that we are increasing in exponents, and if we remember our exponent properties, if we take 3/10 divided by 3/5, as I'm saying that wrong, I realize that I'm so 3 raised to the 10th power and 3 raised to the 5th power. Just like with y'all getting used to these videos, I'm definitely getting used to these videos. But if you remember with your exponent properties, you simply just take them and you subtract them. So our common ratio is 3 to the 5th, which means our next term of the sequence is 3 to the 25th. Okay. All right, so we've already talked about that. Same thing from yesterday. We're going to talk about if something is geometric or arithmetic. Take a few seconds to look at those. So the first one, if you look at it, we are adding by 5, but then multiplying by 5. Or we're multiplying by 2 and multiplying by 5. So in this case, this one would be neither of those. Okay. The next one, it looks like we are adding 9 or subtracting 9. So in other words, we have a common difference of -9. So this one has to be arithmetic. And lastly, we are multiplying by 2. So we have a common ratio of 2, which means this one is geometric. Remember one of these having a typo. I think this one was it. Yeah, because this should not be geometric. Same notation as arithmetic because they are both sequences. Remember, we have our first term, which is a sub n, second term is a sub 2, and so on. Okay, without even knowing a formula, go ahead and find the 8th term of each sequence. All right, so if we keep dividing by 4 or multiplying by 1/4, we would get 1 and then 1/4. And then from there, we keep going until we get to our final term. Now, when we're looking at these, sorry, I was making sure my screen was still recording us. When we're looking at these, there's a formula, of course, that is going to make things a whole lot easier. So we don't have to keep dividing by 4, dividing by 4, dividing by 4. Yesterday, we talked a little bit about trying to get away from calculators. So if I want to take 1/4 and divide it by 4. If you remember 1/4, we can multiply by the reciprocal. So that gets us 1/16. And if we continue and we get 1/16, and we also divide that by 4, and we get 4 times 16, which gets us 1/64. Okay. Here it looks like we are multiplying by 3. And some of us don't necessarily need to write these down every single time, but some of us might need that extra support, because if we start writing these down, then we can actually see, oh, I've only done 3 of them. I need to do a total of 4. So then I get the 10, 9, 3, 5. Okay. Again, pretty straightforward and simple like it was yesterday, so hopefully it shouldn't be too much of an issue. All right, so let's look at the explicit formula. Same things as before. This is our nth term. This is our first term. Our common ratio. And our nth term. Our term number. Same meanings for each variable like it was yesterday. Again, pause it if you need more time. All right, so the good news with this one compared to yesterday is that when you're writing out the formula, you don't have to worry about distributing and then combining like terms. Once you write out the formula, then you're done. So if I take a sub 1 or a sub n, and my first term is -10, my common ratio is -0.6, raised to the n minus 1. I'm done. I cannot multiply the -10 and the -0.6. Same thing goes for over here. We have our first term, our common ratio, raised to the n minus 1. So if it asks you for the first 4 terms, again, nothing is stopping you from saying, okay, I can take 10 and multiply it by -1, multiply it by -1, and multiply it by -1 again to get my sequence. Or you can easily keep plugging in to n. You can plug in n equals 1, n equals 2, n equals 3, n equals 4, and so on, all the way up to whatever number you're looking for. Okay, so before, just like yesterday, I can give you the first term in the common ratio, or I can just give you the sequence. Either way, it's up to you then to say, in this particular case, our first term is -5. Our common ratio is -2 raised to the n minus 1. If you don't know how to go forwards, you can always go backwards. So 4/10 reduces to 2/5. So I can say my a sub n is equal to 10 times 2/5 raised to the n minus 1. Okay, so with arithmetic, we were able to write out, if this is our first term, second term, third term, fourth term, fifth term, sixth term, and we wanted to know how many, so in the arithmetic we did how many common differences. So with geometric, we're going to find out common ratios. Okay, so if I take 625 times, looks like I have 5 common ratios. So instead of saying 5r, which would imply you're adding them, we need to do r to the 5th. Okay, so when we're looking through these and we divide by 625, and what you can do is you can keep this in your calculator as you're going through, because then you're going to have to take the fifth root of your answer and conveniently you also end up with 0.2. Now the issue that we're going to come in contact with is that could it possibly be positive or negative? So if you think about it, if I'm going, let's go ahead and fill in our sequence. So go ahead and do so. So what I could do is I could look at it and say, well, if it was negative, so this would be negative, this would be positive, this would be negative, this would be positive, so this would be negative, but it's not. So in that particular case, we would say that it can't be negative and that what we just did is not going to be possible. Whoops, and there's my wedding photo. Okay. Same for this one. We use, what do we have? What do we know? We know our fifth term. We know our common ratio. So what they want to know is the explicit formula. And of course, that's our a sub n equals a sub 1 times r to the n minus 1. So what I'm missing, I know my fifth term. I don't know my first term. I do know my common ratio. And I do know that this 5 down here is my n, so 5 minus 1. So I can solve it this way, or I can use common sense, like I said, you can use in this whole chapter. If this is your fifth term, all you have to do is go backwards to find your first term. Either way, it does not matter how you want to approach that. Go ahead and finish that one out. Okay, so whether you went backwards or you went ahead and solved up here as well, but you should find that your a sub 1 is 6, your common ratio is 4, and then your n1 is 1. And they can turn around and then ask you any question they want to from that. Okay, so with arithmetic mean, we were able to add two numbers together and divide it by 2. With geometric mean, we are multiplying, taking the square root, and then including that plus or minus, because again, we don't know if it could be possible that it's positive or negative. Okay, so for example, if I take 28 times 448, underneath the square root with the plus or minus, I get 12,544. And if I take the square root of that, I get 112. So I look at this and I say, is it possible for this to be positive or negative 112? Okay. Well, if you notice, we're multiplying by 4. So if I did multiply by positive 4, we would have a positive answer. If we were multiplying by a negative 4, we would have a negative answer. So yes, we want to include both of the positive and the negative in both of those. Looking at the next one, we don't just have 1, so we can't do the geometric mean there. But we do notice that we're multiplying by 2 common ratios, or sorry, 3. I'm writing number 2 and meaning to say 3. I take 128 divided by 2, and then I take the cubed root of 64. So we can look at, okay, well, is our common ratio going to be positive and negative 4 or just positive 4? So if I multiply by 4, I get 8, then 32. If I did negative 4, it'd be negative 8, positive 32, but then a negative 128. So this is not an option. So our common ratio is just a positive 4. Again, if you have any questions while we're working through these, please make note on them and then come to office hours. Okay, so let's go back to this question. Which would you prefer? Being given $1 million or 1 penny for the first day and double that penny the next day and then double the previous day's pennies and so on for a month. So if we look at it, day 1, you have 1 penny. Day 2, you have 2, and then it just keeps going. So go ahead and calculate how many pennies you would have on the 30th day. So if we raise it to the 29th, because if you notice you're on the 3rd day, you're 1 less over here. 2nd day, you're 1 less over here. So 30 would be 29. So that is 536, 870, and 912 pennies. And if I wanted to know how much that would get me in actual dollars, then I would move the decimal place twice. So personally, I would prefer to have about $5 million as opposed to $1 million. Same thing as we did yesterday. We want a graphical representation of the sequence that's going on. So if we're multiplying by 3, this one's going to look a little bit different. You also noticed our equation that we were working with. It kind of gives you a hint to what kind of graph you're going to see. But if not, our first term is 1, second term is 3, our third term is 9, and our fourth term is 27. So if I graph that, and so on, if you notice, it's exponential. Okay? And just as you can see, if you were to look at the actual formula itself, we're dealing with that exponent right there. Okay? So let's put it all together. So with arithmetic and geometric, we're looking at the 2 different formulas. We're also looking at the means, our graphical representation, and then we're going to look at our finite and infinite sums when we start talking about series. So again, if you are someone who needs a graphic organizer of some sort, pause it, go ahead and write all this stuff down. Okay, go ahead and begin our geometric homework. It should be, again, like I said, pretty straightforward. Just watch out for the plus or minuses when you're trying to figure out the next term or the two terms that are missing or anything of that nature. And that is all for today.